Hey everybody, this is Mr. Ainsworth, and we're going to get into a topic called simplifying square roots or simplifying radicals. But before we do, we need to know what the first 20 perfect squares are, because if we know these, then we know how to square root the number, then we can simplify the roots. Okay, so the first goal here is not to just go right into simplifying roots, it's to know what the perfect squares are, because you need to know those in order to square root a number. So let's do that. Let's talk about it. Let's take 1 squared, that's 1. All right, 2 squared, that's 4. 3 squared, that's 9. 4 squared, that's 16. These you should all know, at least up to the 12 squared. 5 squared is 25. 6 squared, 36. 7 squared, 49. By the way, this is a video, so if I go too fast during my lesson here, you feel free to pause and play, rewind, and go back and listen to any section that you want. Alright, that's if I go too fast. 8 squared is 64. 9 squared, 81. 10 squared is 100. 11 squared, 11 times 11, 121. 12 squared, 144. You should know all these since grade school, because you were required to know your 12s in your multiplication tables. All right, the question is, do you know the rest? Okay, 13 squared is 169. 14 squared is 196. It has to end in a 6 because 4 times 4 is 16. All right, 15 squared has to end in a 5 because 5 times 5 is 25. It happens to be 225. 16 squared has to end in a 6 because 6 times 6 is 36. We get 256 here. 17 squared gives you, well, first of all, it ends in a 9 because 7 times 7 is 49, so it has to end in a 9, so it's 289. 18 squared has to end in a 4 because 8 times 8 is 64. Let me see if let me repeat myself because I'm not sure if I said it correctly. 18 squared has to end in a 4 because 8 times 8 is 64, so it happens to be 324. All right, and 19 squared is 19 times 19, has to end in a 1 because 9 times 9 is 81. You get 361. 20 squared times 20 times 20, 400, and the list goes on and on. All right, these are the squares that you need to know. And then if you know your squares, you know your roots. All right, for example, the square root of 196 gives you 14. The square root of 196 gives you 14. Why? Because 14 squared gives you 196. All right, the square root of 361 I know is 19 because if you square 19, you get 361. All right, if you know your squares, you know your square roots. The square root of 225 is 15 because 15 squared is 225. So what we need to do is we need to get these squares down really well in our mind, know them by heart, have them all memorized so you can apply them. So let's get right into it. The first rule in algebra dealing with roots is this one right here, and it states, and take a look at right here, states that if you take the square root of a times b, it's equal to the square root of a times the square root of b. Now, just like 2 times 4 gives you 8, okay, 2 and 4 are called factors of 8, these two are called factors. All right, and what this is saying is that you got to square root each individual factor. Okay, so let's write that down. Square root, all right, both factors. You're going to see me do that in all of our examples right here. We're going to square root both the factors after we factor the number, and we're going to simplify the one involving the square. So let's take a look at how it's done here. Let me play with some numbers here. Let's take a look at root 18. Now we have some couple potential possibilities for factors of 18. We know that 3 times 6 is 18. We know that 2 times 9 is 18. But what's the better choice? So let's analyze one by one, okay? We're going to split the root into 2 factors. A root times root is a root. Okay, so the root of 3 times the root of 6 is the root of 18. Root 3 times root 6 is root 18, because 3 times 6 is 18. But the question is this a good choice? And so what we do is we go back up to the very top. All right, are 3 and 6 squares? That's the big question. And the answer is no, because the first few squares are 1, 4, 9, and 16. 3 and 6 are not squares, and so this would be a good example of a bad choice. So let's write that down. This is a bad choice of factors. Don't choose these. These are not squares. you shouldn't choose the numbers that aren't squares. You got to find one that is a square. So a better choice for splitting up root 18 would be using 2 times 9 or 9 times 2. So I always put the square first personally because that's the one you're going to be simplifying. All right, so you're going to split the root. You're going to square root both factors first. All right, step 2, you simplify it. And we know that the square root of 9 is just 3, so we get 3 times root 2. Or what we say is 3 root 2, written just like this, 3 root 2. Okay, so what we do is we square root both of the factors right here. Square root, all right, both factors. All right, that's your step 1. Step 2, right here, you simplify the result. All right, and that's all you do. And the way you say this is 3 root 2. We say 3 times radical 2, or 3 rad 2, or 3 root 2, or 3 times the square root of 2. All the same number. All right, 2-step procedure. You square root both of the factors, and you simplify. And that's how the game is played. The only hard part comes in when the numbers get big, like 3-digit numbers. We'll talk about that later. All right, so let's get into it again. Let's take root 12, and let's analyze. Now, I know that 2 times 6 is 12. I know that 3 times 4 is 12. I know that. So let's analyze. So let's take the square root of 2 times the square root of 6. But notice, 2 and 6 aren't squares. They're not on that list above there. They're not squares. So once again, this would be a bad choice of factors. Okay? So you shouldn't choose 2 and 6 because they're not squares. You should choose the 3 times 4 because 4 is your square. So you have root 4, always write the square first, times root 3. You square root both of the factors, and then you simplify it. Root 4 is just 2, so we get 2 root 3. You could say it 2 root 3, 2 rad 3, 2 times the square root of 3, whatever your preference. Okay? All right, let's try another one. Let's try the square root of 24. We're going to split that root 2. Now we know that 2 times 12 is 24. I know that 3 times 8 is 24. I know that 4 times 6 is 24. I know that. I know. Okay, why? Because you know your multiplication tables, right? But what are good choices? Well, 2 and 12 are not squares. I wouldn't approach it like that. 3 and 8 aren't squares. But 4 is a square. I would choose this one. This is the best choice right here. So let's split it as root 4 times root 6. Root 4 is just 2, so you get 2 rad 6 or 2 root 6. Now, if you did use the 2 and 12 as factors, you could do it like this, I suppose. You could split it up like this. Square root of 2 times the square root of 12. All right. I suppose you could... No, I wouldn't do it like that. Still wouldn't do that like that. It's not a good choice. You'd have to keep on simplifying root 12, so I wouldn't even choose that. Let's just stay with what we did in the very beginning here. All right, let's try another one. Square root of 50. We have a couple choices. We have 5 times 10 is 50. We have 2 times 25 is 50. Now, since 5 and 10 aren't squares, that's a bad choice. Here's your square right here. That's your square, so you should use your factors of 2 and 25 and write 25 first. Always your square first. So you have square root of 25 times root 2. The square root of 25 is just 5, so you get 5 root 2 as your end result. It's a simple 2-step procedure. Okay? All right, now what do you do when the numbers get bigger? Well, let's talk about that. So turn on the next page. Let's take a look at this. I always tell my students to factor first. If you don't know what the factors of 120 are, then factor it first and find them. And I'm going to show you a technique that's a little bit different than what you did in grade school. In grade school, you did a factor tree that looked like this, 120, and then you factored out and you put out your tree here, your branches, and you did 2 times 60 is 120, and then you branched out again, and then you branched out again, and then you branched out again. You got factors all over the place. All right? We're not going to do it that way. We're going to do what's called a vertical factor tree and line up all the factors on the right-hand side. You'll see why in a minute. I saw this technique from a person back in 1996 when I was teaching, or when he was teaching at Anaheim High School. And it was so efficient, so effective, and his class dominated over everybody else that I started using it, and I've had the same results. My students that come back after knowing this technique always are faster and better than everybody else, and I've been teaching it ever since then. So here we go. When you factor a number here, always start off factoring by dividing the number, if it's even, by the smallest prime number possible, which is 2. All even numbers are divisible by 2. So since 12 divided by 2 is 6, 120 divided by 2 is 60, divided by 2 is 30, divided by 2 is 15, divided by 3 is 5, and 5 is prime, so just divide it by itself and you get 1. And when you're done when you have the last number being 1. All the numbers on the right multiply to 120. 2 times 2 times 2 times 3 times 5 is 120. The question is, where's your squares? And that's easy to find because I know that 2 times 2 is 4. Now, the other remaining factors, 2 times 3 times 5, they don't produce a square, but they do produce 30. 2 times 3 is 6, times 5 is 30. So they produce a factor of 30. And these are the ones that we square root, just like we did previously. You square root both factors. So you take the root 120 and you split it into 2 roots, a root times a root. Put your factors in. You got the square root of 4 times root 30. Square root of 4 is 2. And you get 2 root 30 as your end result. And you're done. Now you can't factor or you can't simplify the root of 30 because the factors are all prime. 2, 3, and 5 are all prime. So you can only simplify the one with a square involved. Okay? You're looking for squares, and that's what this game is all about. So let's take 180 over here and let's do the same thing. Let's start dividing it by 2. You can pause the video and work ahead if you'd like, and then press play when you're ready. But 180 divided by 2 is, 18 divided by 2 is 9, so 180 divided by 2 is 90. Divided by 2, 45. It's divisible by 5 9 times. 9 is divisible by 3 3 times. Divided by 3 is 1. Now, check this out. I see a square here and I see a square here. And what you need to learn is that a square times another square gives you a bigger square of 36. 36 times 5 is 180. And I bet you didn't know that initially, did you? All right, but you do now. 36 times 5 is 180. So we're going to take 180 and we're going to split it as root 36 times root 5. Well, root 36 is just 6, and so my end result is 6 root 5. And that's all there is to it. You just play the game. You factor the number and you look for squares. Take 175 off to the side. Divide it by 5 because it ends in a 5. 175 divided by 5 divides in 3 times. Remainder 2. 5 into 25 is 5, so it divides 35 times. Divided by 5. 7 divided by 7, 1. I can already see that 7 times 25 is 175. So those are my factors. So I do the same thing. I split it into 2 roots. So the square root of 25 times the square root of 7 gives me 5 root 7. Because the square root of 25 is just 5. It's a 2-step procedure right here. Step 1, square root both factors. Step 2, simplify. 2 steps only. All right? And what you need to do is just play the game and get good. All right? So let's do that. Let's take root 68 and simplify it, and pause and play in the video now. All right? Pause the video and get started. Take 68 off to the side and get started, and play when you're ready. All right, let's check your table first. 68 divided by 2 is 34. Divided by 2 is 17. That's prime, so you divide it by itself. And those are the factors right here, 4 and 17. So you square root of 68 is the square root of 4 times the square root of 17. And you get 2 rad 17. All right? Now try the next one. Pause the video and go. Okay. So if you want to, do this by table, you could. But I already know that the table is really not needed because I know that 9 times 10 is 90. So when it's that simple, just split it immediately. Most people know that 9 times 10 is 90. So if you split the root into root 9 times root 10, you get 3 root 10, and you're done. No table needed. All right, not if you see the factors. Okay? Not when it's that easy. All right, next one. Let's take a look at this one here, root 98. Let's take it off to the side. and let's factor it. Pause the video and go. Alright, let's check it. We got 98 divided by 2 is 49. Divided by 7 is 7. Divided by 7 is 1. There's my square. So I can already see the factors. 2 times 49. So the square root of 98 is the square root of 49. I always write the square first. Times root 2, giving you 7 root 2. Okay? Try it again. Take 78, factor it, pause the video, and go. Alright, let's start dividing by 2. You get 39. Divided by 3, you get 13. It's prime divided by itself. And since all of these are prime, all prime, that tells you that you cannot simplify the root because there are no squares. They're all prime and no squares. So that tells you that you cannot simplify the root. Alright? And you're done. Go to the next one. Alright, take the square root of 32 and split it up. We'll factor it first. Pause the video and go. Alright, let's check. 32 divided by 2 is 16. Ooh, 16 is a square. I should probably stop. Those are my factors. Okay, so the square root of 32 is the square root of 16 times the square root of 2. Well, that's just 4 root 2 and you're done. Alright? Alright, and the next one, square root of 116. So let's take 116 off to the side. Pause the video, start factoring. 116 divided by 2 is 58. Divided by 2, 29. That's prime. So there are my factors, 4 times 29. You got to square root those guys. So the square root of 116 is the square root of 4 times the square root of 29. And you get 2 rad 29. Okay? And last one, let's take 218 and let's factor it off to the side. Pause the video and get started. Alright, divided by 2 you get 109. It's 109 prime. It's not divisible by 2 nor 3 because 1 plus 9 is 10. That's not divisible by 3. It's not divisible by 5. Ooh, these are prime. Okay, so it cannot simplify. One more time. Okay, and that's how the game is played. You just have to come to class, work with me. We'll take these skills and apply them in other lessons here. And again, this simplifying comes up a lot in geometry and algebra 2 and other classes. So we'll practice it heavily here with me, and we'll apply it in future lessons, and I'll see you in my next video. This is Mr. Ainsworth signing off. I'll see you later.